Okay, so now we will understand about placing of leads. So the ECG leads, the two electrodes of ECG leads are placed over the different areas of the heart, as we can see in our in patients also. We place different electrodes on different parts of the body. So it is placed over different areas of the heart and connected to a galvanometer, which picks up the electrical currents resulting from the potential difference between them. The resulting tracing of voltage the resulting tracing of voltage difference at any two sides due to the electrical activity of the heart is called a lead. So it is the definition of lead. So what is lead? It is saying that when the voltage difference between the two sides, okay, when we measure the voltage difference between these, suppose the two sides, then this whole system is called a lead. Okay, so the first type of lead placing is the bipolar leads. In bipolar leads, ECG is recorded by using two electrodes such that final trace corresponds to the difference of electrical potentials existing between them. They are called standard leads and have been universally adopted, and there are sometimes it is also referred to as Einthoven, Einthoven leads. In standard lead 1, the electrodes are placed on the right and the left arm, that is RA and the LA. And in lead 2, the electrodes are placed on the right arm and the left leg. So now this is the lead 1, the right arm. Let me take a highlighter. So the right arm and the left arm, it is the lead 1. Okay, as you can see, it is the lead 1. And then in lead 2, the electrodes are placed on the right arm and the left leg. The right arm and the left leg. This one. Okay. In lead 3, they are placed on the left arm and the left leg. On the left arm, on the left arm, and the left leg. Okay. In all lead connections, the difference of potential measured between two electrodes are always with the reference to the third point on the body. This reference point is conventionally taken as the right leg. So we use a conventional point to take the potential difference, and this is mainly taken as the right leg. The records are different, therefore made using the three electrodes at a time, the right leg connection always being present because it is using as a reference point. In defining the bipolar leads, Einthoven postulated that any given instant of the cardiac cycle, the electrical axis of the heart can be represented as a two-dimensional vector. So it it is basically saying that we can represent the electrical axis as two-dimensional vector. The ECG measured from any of the three basic limb leads is time variant, single dimensional component of the vector. He proposed that the electric field of the heart could be represented diagrammatically as a triangle with the heart ideally located at the center. The triangle is known as the Einthoven Triangle. So here you can see in this figure, here is the lead one, as we have studied previously. Then here's the lead 2 and here's the lead 3. And we have also said that the right leg is always used as a reference point. Okay. So this triangle made from using these three leads is used to represent the electrical axis in a two-dimensional vector. Okay, so as we have studied in class 11 12 vectors and forces, so we have seen that if one vector is going in this direction, the other is going in this direction, and the fourth one is going in this direction. So the resultant vector will be in this direction. Okay, so basically it is taking the resultants of the vector. The sides of the triangle represent the lines along which the three projections of the ECG vector are measured. It was shown that the instantaneous voltage measured from any of the three limb lead positions is approximately equal to the algebraic sum of the two other, and the vector sum of all projections are three lines is equal to 0. It is saying that the algebraic sum of the other two, or that the sum of the projections of all three lines is equal to 0, that 1 plus 2 plus 3 will be equal to 0. In all the bipolar lead positions, QRS for a normal heart is such that R wave is positive and greatest in lead 2. Okay, we have seen above the QRS. You can see here the QRS. It is saying QRS for a normal heart is such that the R wave is positive and is greatest in lead 2. Okay, this is completely the observation of the recording part. Coming on to the unipolar lead placing, the standard leads record the difference in electrical potential between the 2 points of the body produced by the heart's action. Quite often, this voltage will show smaller changes than either of the potentials, so better sensitivity can be obtained if the potential of a single electrode is recorded. In this arrangement, the electrocardiogram is recorded between a single exploratory electrode and the center terminal, which has a potential corresponding to the center of the body. The reference electrode or the central terminal is obtained by combination of several electrodes tied together at one point. So this technique is mainly used to obtain better results in the ECG. So two types of unipolar leads are employed, which are the limb leads and the precordial leads. Okay. Limb leads, there are two limb leads. As the name suggests, limb is related to the limbs. They are tied together and recorded with respect to the third limb. In the lead identified as AVR, the right arm is recorded with respect to the reference established by joining the left arm and the left leg. As you can see, right, left, one, left, like this. In the AVL lead, the left arm is recorded. Firstly, the right arm is recorded, then the left arm is recorded, but with respect to the common junction of the right arm and the left leg. Then AVF, the left leg is recorded with respect to the two arms electrode tied together. They are also called augmented leads or the averaging leads. The resistances inserted between the electrode machines connection are also known as averaging resistances. Here you can see the all the three recordings of the unipolar limbed lead pacing. So coming on to the precordial leads, the second type of unipolar lead is called a precordial lead. It employs an exploring electrode to record the potential of the heart action on the chest at 6 different positions. These leads are designated by the capital letter V followed by a subscript numeral which represent the position of the electrode on the precardium. The positions of the chest leads are shown in this figure. If I zoom into this figure, you can see that these are the chest leads. Okay, the V1, V2, V3, V4, V5, V6. Okay, and with V3, VE. Okay, so the V1 is the fourth intercostal space. Here, this is not that important part. The important part that important is the function of these chest leads, and the V leads are here. So it is it is mainly the basic diagram of what we are doing to record the ECG. Like we are connecting this thing to our leg, this electrode, this lead to the leg. The left arm is also connected to the leg. Okay, then the right leg is, as you can see, used as a reference point in the above situation, and these are the buffers. Okay, so this is all about the electrocardiograph and the electrocardiogram, and mainly we have to this is all the theory portion, so mainly we have to learn all these things, and this is all from my side about electrocardiogram and electrocardiograph. So thank you so much for watching this video, and I hope you get some knowledge about the electrocardiogram and about ECG, and stay tuned for more.